Hello friends, welcome to my YouTube channel Mech Maharashtra, which provides you educational videos. Now the last part, which we have seen the force analysis and their numericals. Now next part is, which is I think last part of this worm gear design, that is calculation of beam strength and wear strength in the worm gear. So as the previous gears such as a spur, helical, we have calculated beam strength, wear strength, effective load. In effective load there was two type, that is first one is a velocity factor, second one is a Buckingham's equation. So same here we are going to perform same procedure. So first of all I'll start from the beam strength. Now beam strength is notation FB directly. So beam strength of the spur gear we know sigma B BMY, correct. So that was the for spur gear. In helical gear cos alpha is added, helix angle, and in case of bevel factor was added. Now here see the equation will be same, sigma B BMY cos of lambda. I'll explain one by one the term. Sigma B bending stress, so Y gear I'll explain. Then beams face width B, module, Lewis factor Y, and lead angle. So I'll start with the one by one. So always what was our first step while solving the gear? To calculate which is the weaker part, either bending or wear. So accordingly we'll have to select the value of sigma B, that is bending stress. Now in case of worm gear, what happened, the gears are made up of phosphor bronze and cast irons, so that's why it has having brittle material, so it can be break easily. So definitely the worm material is a steel and gear material is a cast iron, so worm is always strengthened as compared to the gear. That's why the weaker part as a gear we have to consider, and always we need to take for calculating beam strength is sigma BG into B. B means face width. Generally we have taken 10 times module, but right now the circular, both the parts, that pinion and gear are not circular, that's why we are not going to take 10 times module. So that's why you can see this iteration will have to keep twice of module square root of q plus 1, or the value of 0.73 times dw, diameter of worm, in whichever with the larger term coming, larger value is coming, that would be your face width value. Next will be the module, we know it is d by z. Y, Lewis factor, so generally we preferred for 20 degree 0.484 minus 2.865 divided by zg, number of teeth on gear. Likewise for pinion yp, but here gear will have to take because it is weaker part. And lambda we can calculate, tan of lambda is equal to zw by diametral quotient, through which we can easily calculate. So this will be the bending strength, that is beam strength of the worm gear pair. Now second part is a wear strength of the worm gear pair. Now see, general equation was of wear strength is Fw is equal to dp bq So this was the equation for every gear pair. Now what happened, you can see, as I told you, the weaker part is gear. In other gears other than worm gear we'll have to take dp always, that was inbuilt equation. Right now the gear is weaker, that's why we'll have to take dg. Clear? Same. Second, face width we'll have to take here also face width. Now q is called as a ratio factor, and which we have to consider q is equal to twice of zg divided by zg plus zp. So likewise we have to select when teeth are externally meet with the gear pair, correct, and when internally minus will be the sign. But here what happened, the gear ratio is not circular cross section, both gear and worm, that's why this gear ratio is cancelled, and instead of that in we have taken the terminology, one term is diametral quotient, so that value we have added. So here in this equation we have to neglect the value of ratio factor. Then k is called as a wear factor. Generally it has given equation will be for wear strength is always for worm gear case is Fw is equal to dg into b into q cancel, that is into k, it is in Newton. This will be the value of wear strength. Next part is, as per the sequence, step number 3 we can say this will be the effective load. See, effective load, earlier equation was Ka Km into Ft. Ft means tangential force. divided by velocity. Now here we'll have to take a tangential force of the gear FGT. Now FGT, this is for gear, so that's why we can take FGT is equal to PO, output power by velocity of gear, that is PO by VG, and K is nothing but the application factor, KV is nothing but the velocity factor. This can be, we can select from the velocity, grade as well as a manufacturing method, but most of time 99% this value is directly given in the numerical, correct. So by this way we can calculate the effective load. This will be our third step. Next will be, this is in case of the effective load, KV factor is considered. Here we cannot use Buckingham because Buckingham suggested the deformation factor and dynamic load for circular cross section. So worm gear structure is not, both are circular, that's why Buckingham's equation is neglected here in overall worm gear design. Next part is safety factor. We need to check, as I told you, if beam strength, here they have mentioned if beam strength is weaker, so I will have to take beam strength FB is equal to FOS into F effective. If wear strength is weaker, I will have to take FW is equal to FOS into F effective. Same step we need to follow as I told you in a previous session. Clear? Likewise, we need to solve the numericals on the beam wear, effective load and factor of safety against bending and wear. Very important. Clear? I hope you understood this. The numericals on this I'll cover in next session. Thank you.